All right, today we're going to talk about phase changes. So there's 6 phase changes because there are 3 phases. And so you have gas. So remember, gas molecules look like this. Oops. Gas particles look like this. Let's see if you're going to work it. Where they're really far apart. Liquids are closer together, but they have movement. Gas particles have movement as well, and then solids. So if we remember that gases have the highest kinetic energy, solids have the lowest kinetic energy. Remember, kinetic energy is the energy of movement. That would be good to remember. So then these arrows in between, so for example, if I went from a liquid to a gas, that's evaporation. But if you reversed it, if you want a gas back to a liquid, that's condensation. Solid to a liquid would be melting, liquid back to a solid is freezing. And then the ones that maybe you haven't heard as much is solid to a gas is called sublimation. So most people know dry ice. Dry ice is actually solidified carbon dioxide. And actually it goes straight from solid to gas form without hitting a liquid. We call it sublimation. And then deposition is from a gas to solid. Sometimes you'll see this up in the mountains. So when it gets super cold, what happens is the gas in the air, it will kind of turn directly into a solid. It almost looks like it's glittering in the air. So we have that. And then so these phase changes are either endothermic or exothermic. And so endothermic is when they require the addition of energy, and then exothermic is when they release energy. So let's think about the phase changes that are exothermic. So these are processes that release energy. And so when you release energy, that means, if you think about it, you're going from a higher kinetic energy to a lower kinetic energy. So if we think of exothermic as, say, you have this gas. So this has a lot of energy. So this is high kinetic energy. As we lower the kinetic energy, these molecules start moving slower. And so the attractive forces, or the IMFs we talked about, actually can come into play, because as they move more slowly, as they pass each other, what happens is now they can be more attracted, and so they could turn into liquids. So at this point, this we would consider exothermic. Why? Because in order for a gas to turn into a liquid, the gas particles have to lose energy in order to allow the IMF to bring them closer together. And so this would be an example of an exothermic reaction. So anytime you're going from a higher energy state to a lower energy state, you need to release energy. That energy has to go somewhere. And so from gas to liquid, we call it condensation, right? So in terms of exothermic reactions, you have condensation. What else? Freezing, and then deposition. So these are going from high energy states to low energy states. That would be deposition. So freezing is going from a liquid to a solid. So you have to lose energy to become more ordered in the crystal-like structure. Deposition is highly exothermic, right? It's the most exothermic if you think about it. So you're going from a gas state, which has high kinetic energy, to a solid state, which is low. Endothermic is just the opposite, right? Endothermic is where you have to add energy to overcome the IMF in order to start moving more quickly. So when you melt, you're going from a solid to a liquid. When you vaporize or boil, we'll just use vaporization. And then sublimation, requires the most amount of energy. Why? Because when you sublimate, you're going from a solid directly to a gas. Oops. Okay. So one of the phase changes, evaporation and vaporization, we want to talk about further. So evaporation and vaporization, actually, they're two different things. Vaporization is actually the general process in which gas turns into vapor. Evaporation is a type of vaporization, but if you add the energy slowly, what will happen is the vaporization only occurs at the surface. This makes sense because of surface tension. If you think about it, if we have a molecule at the surface, so let's just call this the surface. If you have a molecule here of liquid, these guys are being held on, but there's the surface area, and so you imagine that these are liquid particles. What I want to see, it's not really well drawn, but this particle, which I'm going to color in red, is kind of being held on all sides, right? So it has attractive forces that's allowing it to be held in place on all sides. However, if you look at the surface, which I'll color in green, there is a side where there is no particle that is holding or attracting it. There's no IMF, say, from the top, right, from the surface, where it interfaces with the air. And so if you look between the red and the green particle actually experiences lower IMF. Why? Because it's in contact with the air, and so there's a part where it's not being attracted, or there's an area where there's no IMF being experienced. And so therefore, this is the one that's likely to leave first. Why? Because it has less, or experiences less IMF. And so that's what occurs during evaporation. All right. And so during this, there's something called vapor pressure. So we can measure vapor pressure. It only works in a closed system, and the reason is because you have to trap the vapor. So as molecules vaporize, what happens is, and you can kind of see in this animation down here, that those particles at the surface, molecules at the surface, escape and become vapor. But since you've trapped it, what it does is remember we talked about pressure being the number of collisions against the surface. Well, those gas particles are moving, and they actually exert a pressure down on the liquid itself. And we call this vapor pressure. And so vapor pressure becomes important when we talk about boiling point, how you can either raise boiling points or lower boiling points. Vapor pressure is important in that aspect. So tomorrow you have a quiz, and so I have posted the quizzes for you.